So we're going up. So we're gonna have to either add or multiply. If we add 4 here, can we add 4 here? No. So we know that it can't be adding. So let's try multiplying. What do we need to multiply to get from 1 to 5? Times 5. From here, times 5. And once you have 3 of something, that's your pattern. So we times 5. And that answer is 3125. So number 2, once again, we're increasing. So from 4 to 6, I can multiply by 1.5, but I don't think that's the pattern that we want. So let's keep going. So we can do from 4 to 6, we can add 2. Oops. So from 4 to 6, okay, from 4 to 6, we're gonna add 2. Then from 6 to 10, I gotta add 4 though. I don't know why it keeps doing that. We're gonna add 4. And then from 10 to 16, we're gonna add 6. And you guys already see the pattern, right? Plus 8, plus 10. So that means we have to plus 12. So 34 plus 12 is 46. So that's your pattern. So let's go to the next one. Okay, this one seems a little bit harder because it's really big numbers. So from 7 to 21, these numbers are getting really big really fast, so it seems we're gonna have to multiply. So from 7 to 21, we're gonna multiply by 3, but from 21 to 84, we can't multiply by 3 because 21 times 3 is 63. So it looks like we have to multiply by 4. Okay, so let's see if we multiply this by 5. 84 times 5, using my calculator right now, is 420. 242 is not 420. So that means we have to figure out what are we multiplying that by to get, what are we multiplying 84 by to get 252. So let's try, see if we multiply by 3, if I'll get the same thing. And I do. So we gotta multiply by 3. So this looks so far like we're doing times 3 times 4 times 3. Let's see if this is times 4. If 252 times 4, yep, it's 1008. So that means our pattern, so for the next one, we're gonna have to multiply by 3. And that will give us this one. This will be on your test, this one. This one's a little bit harder, right? So I'm warning you guys right now. Please make sure that you understand how to recognize patterns. It doesn't just have to be times 2, times 3, times 4, times 5. It's gonna get harder, and you're gonna need to know how to do all of them. Okay, this one's pretty hard. So, let's look at this one. Ignore all of this because I do not like to look at the answer choices when I'm recognizing patterns. I like to see the pattern for myself. So there's a couple criteria. Oh, and they give us to right here. Look, there's 3 criteria in all of these figures. In all of these, there's 3 things we can look at. Let's highlight them. The shading style, the shape, and then the appearance. So I guess the appearance is just, they want us to figure out what is the 16th figure. So this one's the 1st, 2nd, 3rd, 4th, 5, 6, 7, 8. So we want to figure out the 16th, what that's going to look like. So let's see. Let's first look at the shape. I think the shape will be easier. So my shapes are circle, triangle, square, star. Circle, triangle, square, star. So what is it going to be on 16? Well, if we take a look here, 1 are circles, 2 triangles, 3 squares, 4 stars, 5 circles, 6 triangles, 7 square, 8 stars. So it looks like every time we go up by 4, we get a star. So if from 4 I get a star and 8 I get a star, where do you think we're also going to get a star? At 12 and at 16. So we know that this is going to be a star. I do not know how to draw. Okay, that was awful. Okay, I'm going to draw a star the old school way, like that. Okay, so we know we got a star. Now, let's look at the shading. Okay, so let's look at the shading right now. So this is blank, dark lines. Blank, dark lines, blank, dark and the next one will be lines. So this is a little bit harder because now we're not going up by 4. Every fourth, we had changed the shape. Now what are we doing? Every 3, right? We have blank, shade, line, blank, shade, line. So every third figure, we're changing the way that it's shaded inside, whether if it's blank, shaded all the way, or with specific lines. Okay? So now, where does 16 fall in that? So we know that every third is a line. So let's do by 3. So 3, 6, 9, 12, 15, and 18. So let's look at 15. So at 15, I had a what? A lines. So after 15 would be what number, guys? 16, right? So after the line shading pattern, what do we have after the lines? Well, we had blank shaded lines, blank shaded lines. So what came after the lines? Well, the shaded part. So we know that our star is going to be, oh, my bad, the blank, I meant to say blank, is going to be blank. So my star is going to have no shading. So far my criteria are star and blank. Okay? So it looks like it's going to be a blank star. So let's see what the answer we got is. Let's erase all this and see if we did it right. Okay, unshaded. Maybe I should have said that. So if you guys were thinking blank or unshaded, that's okay. So we figured out our pattern just by looking at what was given here. Do not pay attention to this. This is here to trick you. This is here to make you second guess yourself. You're gonna have these blank, by the way, obviously. I like to give the answer. I like to show complete because it saves a lot of time. So we know that this is gonna be blank, and when you click on it, it's gonna be like a little drop down thing right here, with like a little thing you click, and it's gonna give you 2 or 3 options or something like that. So try not to look at that, because then you're just at a 50-50 guess. Try to figure it out on your own first. So we got that it was blank or unshaded, and we got that it was a star. So what's the whole thing? An unshaded star. So good job. Okay? That one's one of the hard ones. This one will be on your test too. This number 4 is definitely going to be on your test. So let's look at this. Okay, this is a key word, conjecture. A conjecture is like a statement or something that was said or something that's proposed. It's pretty much a phrase, right? Something you're saying. So they're saying, make a conjecture for the following statements. Try a few examples if necessary. So the sum of an even and an odd number. Okay, so they're saying that they pretty much want us, this is kind of a confusing question, but they want us to finish this blank right here. So they're saying the sum of an even and an odd number, what? What does it give us? What should be this finishing word? So if we look at the multiple choices, it all says the sum of an even or odd number, and then it has different options. It's positive, it's negative, even, 0, or odd. So they actually gave us a hint here to try a few examples. So let's try the sum of an even and an odd number. Okay, so 2 plus 3. 2 is even, 3 is odd, so that gives us 5. Okay, let's think of another one. 16 plus 5. This is an even and an odd, so that gives us 21. Let's try one more. Even number 4 plus an odd number 7 gives us 11. So what did we just notice about all of these numbers? What did I notice about this number, this number, this number? And remember, guys, it has to be true all the time. So for example, the sum of an even and an odd number is positive, but it's not always going to be positive. Let's take a look at 3 plus, I don't know, negative 7, right? No, wait. Oh, no, even. So let's do 4. 4. So 4 is an even number. Negative 7 is an odd number. So what is 4 plus negative 7? That gives me negative 3. So what's the difference between this number, this number, this number, and this one? That this one is what? Negative. So one example where it's wrong, you scrap the whole thing. So the fact that it says the sum of an even and an odd number is positive, even though that might be true for these circumstances, it's wrong here. So the whole thing is wrong, okay? And look, once again, it was negative here, but it was positive in the other chances, so you scrap this too. This even is impossible. Nothing we did even gave us even, so this one's wrong. The sum of an even and an odd number is 0. That's actually impossible. Nothing is going to equal 0, so that's just silly. The actual answer is odd, and even here, notice this is -3. 3 is still an odd number. So in every single way that we did the sum of an even and an odd number, what we got all the time was that the sum of of those two numbers is odd. So your answer is E. This one's hard. This one's probably gonna be on your quiz, to be honest. Okay, so let's take a look at the next one. Okay, make a conjecture. So they want another conjecture. Try a few examples. Okay, so the product of two odd numbers. Okay, so product is multiplying. So let's try two odd numbers. So 3 times 7. That gives us what? 21. 5 times 3. It's 15. I'm just producing product, two odd numbers. 1 times 7. 7. So what do we notice about all of these again, guys? These are all what? Odd numbers. So let's take a look here. The product of two odd numbers is even? No, that's impossible. No. The product of two odd numbers is 0. That's impossible because to multiply anything by 0 would give us what? 0. 0 is not an odd number. So that's impossible. The product of two odd numbers is positive, not always. -3 times 5. -15. This is not positive, so this one is wrong. The product of two odd numbers is always odd, okay? In a bunch of examples we've done, the answer was odd, 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 odd. And now the product of two odd numbers is negative? No, we just did 3 examples where that wasn't the case. So this one's also wrong. So the answer is D. So either this one or the other one will be on your quiz. I'm going to put one of these two because I love these questions. Makes you think, right? So, okay, this one, we should know this already. I like this question. The product of a number and its reciprocal. So if I take a number, 5, and I multiply it, product, by its reciprocal, 1/5, what am I going to get, guys? What's the invisible number under this 5? It's always a 1. And we know that when we multiply fractions, we multiply straight across. So what is 5 times 1? 5. What is 1 times 5? 5. What's 5 over 5? 1. Let's do another. 23 times 1 over 23. What does that give us? 23 over 23, which is 1. So the product of a number and its reciprocal is always what? 1. So, good. Okay. Oh, wait a minute. None of these questions are going to be on your quiz because this is 2.2. You see how it says 2.2? So all those questions I just said, they could probably be on your test because your quiz is only 2.3 and 2.4. So sorry about that. Okay, so let's keep going. The speed at which a cricket chirps is affected by the temperature. If a cricket chirps 19 times in 14 seconds, what's the temperature? Okay, so let's take a look at the chart. Number of chirps per 14 seconds. So I have 4, 9, and 14. What's the pattern from 4 to 9 and 9 to 14? We're adding 5. So let's add another 5. What will we get? 19. Okay, so that means whatever this temperature is going to be our answer for 19 times 19, right here. So now let's figure out what's the pattern of the temperature increasing by, or decreasing. So it's going from 44 to 54, so we're adding 10. 54 to 64, that's another adding 10. So what is the next one? We gotta add another 10. So this is 74. Okay. This is an amazing question. Find one counterexample to show that the following conjecture is false. Triangle ABC is a right triangle. So angle A measures 90. So I'm gonna draw, ignore these for now. I'm gonna draw two right triangles. Let's name this triangle A, B, C. Let's name this triangle C, A, B. So these are both two right triangles, right? Right triangle, triangle A, B, C, triangle A, B, C, or in other words, C, A, B, right? So let's take a look at this. ABC is a right triangle. So A measures 90. Okay, so they're saying, hey, listen, if I have a triangle by the name of ABC, that means that this measure angle A has to be 90 degrees. So can we draw a triangle in the case where A is not 90? Well, here I drew a triangle that the angle A is 90. Look, right here, triangle A, B, C. So here the angle is 90, but over here, what's angle A? I don't know. I just know that it cannot be 90. Because, guys, what is the measure of an entire triangle? The measure of an entire triangle is 180 degrees. So if this is 90, and then you make the claim that this is also 90, so this is 90 and this is 90, what is 90 plus 90? That's already 180. So where you're just gonna have an angle of 0? That's impossible. You cannot have an angle of 0. So that means it is impossible for any triangle in the world to have two 90-degree angles. So that means this is the example that we can use to prove that, hey, just because I have a triangle that is a right angle, a right triangle, doesn't always mean that measure angle A is going to be the one that's 90. In this situation, this triangle ABC was 90 degrees at the angle A, but this is an example of a triangle that the A was not 90 degrees. Therefore, this is the conjecture. This is the thing. This is the triangle that shows us that, hey, this conjecture is wrong because of this counterexample. Okay? So let's take a look at this one. Find one counterexample to show that the following conjecture is false. Okay, so they're already telling us that this conjecture is false. They just want us to prove it. They want us to give the counterexample. Remember, the counterexample is just a proof or the reason why you're stating something. So let's take a look at two negative numbers. Okay, so let's take a look here. Let's just go one by one. So what is product, right? Product. So product of two negative numbers is always less than either number. Okay. Okay, this question is actually really easy because it's saying the product of two negative numbers. The only multiple choice that has two negative numbers is this one. So that's actually kind of funny because this is already answered. Okay, let's move on. This question is not good. I didn't realize this question was silly, but there you go. So, but just to show you, the product of two negative numbers, if I have -1 times -5, that equals what? 5. It's impossible because what happens when I multiply two negative numbers? What is negative anything times negative anything? It gives me something positive. So how can the product, and we know that the product, another word for product is the answer of a multiplication or the solution of a multiplication, right? So how can anything that's being multiplied, negative and a negative, ever be more than a positive? That's literally impossible. So this is the conjecture that tells us that, hey, this what you just said, we debunked it, and we debunked it with -2 times -3, which is +6, and we know that we know that's impossible. Okay, perfect. So let's move on. Okay, this one looks scary because it's a lot. So let's look little by little. Let's go piece by piece. Clay thinks the next term in the sequence 2, 4. So he's saying that if you have 2 and 4, okay. So Clay is saying that if I have 2 and 4, that the next number has to be 6, okay? Let's do another color. Given the same pattern, okay, so this guy ought says if I have the same pattern 2 and 4, he thinks the next number is 8. Okay, and there's somebody else. And Stacy thinks the next term is 7. So if Stacy has a 2 and a 4, if all three of them got the same pattern, Clay says it's 6. The next number is Clay says it's 6. Odd thinks it's 8, and Stacy thinks it's 7. Okay. What conjecture is each person making? And is there enough information to decide who is correct? Okay, so let's take a look here. Okay, I cut this off because I couldn't fill it all into one, but let's use like common sense. If this is Ott's conjecture and this is Stacy's conjecture, this first one obviously has to be Clay. So let's just write Clay. Okay, so Clay's conjecture, so state Ott's conjecture, states Casey's conjecture. So this is Clay's conjecture. So Clay's conjecture. He's saying that, okay, so let's take a look at what is the reason why Clay thinks this is 6. So he could be saying what? If I have 2 and then 4 and then 6, Clay has to be saying, let's do it in orange because today was orange. Clay is saying that the number is being what? Added by 2. Or we could also say it's 2, 4, 6, 8, 10, blah, blah. So he's also saying it could just be even numbers. So 2, 4, 6, 8, 10. Or we can say adding by 2. So it could either be even numbers, or adding by 2. So let's see what multiple choices they give us. So let's look at this first one. Each number after the first is obtained by adding successive counting numbers starting with 2 to the previous number. Okay, so successive means okay, each number after the first obtained by adding successive counting numbers to the previous. Okay, so he's saying this is 2 plus 2, which gives us 4. So that means 4 plus 4 must be 8. 8 plus 8 must be 16. That's what they're saying, but that's not the case. That's not the case. We're just adding by 2, or we're doing even numbers. So we want to look for something like that. So this one's wrong. The given sequence is a sequence of even numbers starting with 2. Okay, that sounds good. Each number after the first is obtained by squaring the previous number. Okay, so 2 squared is, no, 2 is just there. So 4, it's saying that this is 2 squared. But that's true. 4 is 2 squared. So now let's do it again. What is 4 squared? 4 squared is 16. Is this 16? No, this is 6. So this one is wrong. Each number after the first is obtained by multiplying the previous number by 2. So what is 2 times 2? 4. What is 4 times 2? 8. Is this 8? No. So Clay's conjecture has to be B. That he's saying that this is just a sequence of even numbers. So now let's look at Ott's conjecture. So if Ott went from 2 to 4 to 8, let's see which one of these makes sense. Each number after the first is obtained by adding successive counting numbers starting with 2 to the previous number. So that means, once again, he's saying that this 4 was obtained by adding 2. So now this next one has to be obtained by adding 2 as well. So what is 4 plus 2? 6. So that's not it. So this one's wrong. Each number after the first is obtained by multiplying the previous number by 2. So what is 2 times 2? That's 4. What is 4 times 2? 8. So this one is correct. So our answer is B. Let's take a look at Stacy's. Okay. Each number after the first is obtained by squaring the previous number. Okay, so I mean she's saying that after 2, 4 is obtained from 2 squared, which is true. 2 squared is what? 4. Okay, so what's 4 squared? 4 squared is 16. This is not 16, so A is wrong. Each number after the first is attained by multiplying the previous number by 2. What is 2 times 2? 4. What is 4 times 2? 8. Is this 8? No, so that one's wrong. Each number after the first is obtained by adding successive counting numbers starting with 2 to the previous number. So, what is 2 plus 2? That's 4. What is 4 plus 3? That's 7. So this one is correct. Now, is there enough information to decide who's correct? How can there be enough information to decide who's correct if every person had a justifiable reason for picking the numbers that they picked? There needs to be more information for you to find out who's right, because maybe Clay's right in this situation, Ott's right in this situation, and Stacy's right in this situation. So there is not enough because you can take pretty much, this is a long way of saying that we need more proof in order to have a defined pattern, and just having 2 and 4 is not enough. So the answer is no. Okay, so now that was a hard one. So now we're going on to 2.3. From now on, these are the stuff that are going to be on your quiz. Okay, so let's look at question 12, 2.3. For a conditional statement, P, if P then Q, complete the following table. So if I start with if P then Q, and that's conditional, what do these squiggles mean? These squiggles mean what? They mean not. And what is not? Not is a negation. So how did we go from P implies Q to not P implies not Q? We just did what? We negated the what? The conditional. And what is the negation of the conditional? It's the inverse. Remember, guys, I'm going to do this once. We have conditional, conditional, then we have converse, then we have inverse, then we have contrapositive, and we know, let's use the highlighter, we know that the converse, hello, why is it not working? Okay, we know that the converse and the inverse, we know that the conditional and the inverse are what? Negations, right? The inverse is the negation of the conditional. And we know that the contrapositive is the negation of the converse. And the other thing that we know is that the converse and the inverse are equivalent statements, and the conditional and the contrapositive are equivalent statements. So if the converse is true, the inverse is true. If the converse is false, the inverse is false. If the conditional is true, the contrapositive is true. This is the main breakdown of our 4 statements, okay? So what about here? What did I do to go from P implies Q to Q implies P? What did we do? We just switched them, right? We switched them. And what is the switching of the hypothesis and the conclusion of a statement? That is just the converse, okay? Identify the hypothesis and the conclusion of the conditional. The hypothesis is measure of an angle is 90, and the conclusion is obtuse. Okay, that one's pretty easy. Okay, they want you to combine using the given hypothesis and conclusion, write a conditional statement. We know, what does a conditional statement need to have? A conditional statement needs to have the phrase if, ... or if blank, then blank. So, if the animal's a frog, because we know that this was P, the hypothesis goes first in a conditional. The hypothesis goes first, right? Conditional is P implies Q, or if P then Q. So we know A is the answer. Okay. Write the following statement in an if-then format. Dogs are mammals. So remember, I just want to add an if and a then. So what is my hypothesis here? My hypothesis is the first one, right? Dogs. And the conclusion would be the mammals. So if the animal is a dog, then it is a mammal. Your answer is B. This right here, this would be the what? This would be the converse, right? If this was our conditional, then this would have to be our converse, right? Because we just switched them. Okay, determine if the conditional is true or false. If it is false, find a counterexample. If a polygon has 8 sides, then it is an octagon. That's actually true. So there's no need to find a counterexample. Remember, we only find a counterexample if it's false. So the condition is true. The conditional is true. Write the negation. So negation, all negation is adding the word not. Negation is simple, okay? Don't overthink it. Just put the word not. So an acute angle measures 106. So an acute angle does not measure 106. So an acute angle does not measure 106. So the answer is B. Okay, this is the questions I was talking about. These will definitely be on your quiz, like absolutely for sure. Is the converse, inverse, and contrapositive. So they want you to take this given conditional statement and just find the converse, inverse, and contrapositive. So if I'm in Oregon, then I'm in the West. The converse of that is if I'm in the West, then I'm in Oregon. So converse, A. Now, what is the inverse? So the inverse is the negation of the conditional. And what's the conditional? This one. So if I am not in Oregon, then I am not in the West. So let's look here. It's this first one. Okay, the contrapositive is the negation of the converse. Whoops. So let's look at the converse. Since we already found the converse right here, let's just negate this sentence. So if I'm not in the West, then I am not in Oregon. If I'm not in the West, then I'm not in Oregon. This was just a coincidence that they were all A, okay? Please do not just pick all A on your quiz. That's just a coincidence. Okay? So let's look here. Write the converse, inverse, and contrapositive of the given statement below. So I'm going to be honest with you, I'm pretty sure this I'm going to put on the quiz because it's a little bit easier. And then this one I'm going to put on your test. So the only difference you need to know, and it's not really that difficult, is that to say not in terms of an equation, the word not, since this is an equation, you need numbers and symbols and notations. The not is just this, crossing off the equal sign. So what would be the converse? Okay, the converse, if this is my given conditional, this is the conditional, let's find the converse. The converse is just switching the hypothesis and the conclusion. So it would be if x equals 7, then 4x plus 9 equals 37. And that's B. The inverse is the negation of the conditional. So let's negate this. If 4x plus 9 does not equal 37, then x does not equal 7. And that's B. The contrapositive is the negation of the converse. So let's just switch this up and then negate it. So if x does not equal 7, then 4x plus 9 does not equal 37. And that is C. Okay. For the conditional statement, if measure of angle C equals 98, then C is obtuse, which is in the form P implies Q. So that's a conditional. Identify whether the following statement is converse, inverse, or contrapositive. Okay, so this, I'm gonna highlight it. This is our conditional. They're telling me that this is the conditional right here. And now they're asking me, what is this in relation to the conditional? So the first thing I notice is that I see not and not. So it has to be either an inverse or a contrapositive, because we know inverses and contrapositives are the negations of things. So we know that, okay, let's take a look at this. Sorry. Okay. If the measure of angle C does not equal 98, okay, So let's take a look. So we're seeing this, now let's take a look at this. If the measure of angle C equals 98, so what did we do? Did we switch the hypothesis and the conclusion to go from here to here? No, it's in the exact same format. It's in if P then Q. The only difference from this statement and this statement, so let me write this here. Do we see how this is my P and this is my Q? Hypothesis, conclusion. The only difference between this conditional statement and this new statement is that the P and the Q are still in the same spot, right? Except what did we do? We negated them. And what is negation? The squiggly line. Squiggly line. So what is the statement that has swiggle and swiggle on the P and then the Q? They gave it to us right here. It's the inverse. Okay? So we know that this is the inverse statement. Okay? So next. For the conditional statement, if a figure is a decagon, then it has 10 sides, which is in the form P then Q. Okay, if P then Q, so this is the conditional. So let's focus on that. This is the conditional. Identify whether the following statement is the converse, inverse, or contrapositive. All right, so once again, we know that this is the P and this is the Q. So let's take a look here. If a figure has 10 sides, then it is a decagon. I'm looking at this. If a figure has 10 sides, then it is a decagon. Wait a minute. They did a switch up here. This P is now where? On the conclusion of the second statement. So this was actually the original P, and now this is the Q. Is there a negation? I do not see the word not. I don't see the word not. So that means there's no negation going on. So what is the statement that switches the hypothesis and the conclusion? That is the converse. Okay? Okay. A conditional statement and its related contrapositive are equivalent statements. Yeah, we know that. We know that a conditional and contrapositive are equivalent. Write the related contrapositive statement for the following true conditional statement. So this is saying that this is our true conditional statement, and they want us to write a contrapositive for this statement. So the contrapositive for this statement will be what? Remember, contrapositive, what do we have to do? We have to negate it, right? This is very important, and I went over this in class. When you're negating a not, so like, okay, if I don't study, then I will not fail. Okay, this is not true, right? If you don't study, you'll not fail. So this is false, right? But my whole point is that just because when they ask you for a negation and you already have the word don't, right? Do not and not. When you already have the word not in your statement, the negation of a not is just what? Taking out the not. So you're just gonna, if this is your conditional right here, if this is your conditional, your contrapositive would just be what? Well, first thing we have to do is switch the P and the Q, right? I call the conclusion, and then we have to negate it. So then your contrapositive will be if I study, not if I study. If I, whoops, I don't know why it doesn't want to come up. If I fail, then I will study. My whole point in this is that you just take out, if you already have a statement with the word not, and you want to negate it, you just take it out. Okay? So let's take a look at why I was going over that, because I noticed that this conditional statement has the word not. So that means I'm going to take out this not when I when I negate it, right? Because when we go from conditional to contrapositive, we have to switch the hypothesis and the conclusion, and we have to negate it. So my next, so it should say, if the number is divisible by 2, then the number is not odd. So now you just have to look for this statement within one of your multiple choices, because this is the negation of this, okay? So, okay, so let's find out, okay? The contrapositive is if a number is divisible by 2, then the number is not odd. That's what we got here. So it looks like C is the answer. So let's take a look at this. Let's take a look at each one and see what it is that they thought. Let's see their mistake. The contrapositive is if a number is not divisible by 2, then the number is odd. What was this, guys? This was just the converse, right? Because what did they do? Look, this is if a number is odd, then the number is not divisible by 2. If the number is not divisible by 2, then the number is odd. This was actually the converse, so it was not the contrapositive, right? This A is the converse. Okay, so that's wrong because we want the what? We want the contrapositive. So this is B. The contrapositive is if a number is not odd, then the number is not divisible by 2. This is absolutely nothing. Because what they did here was that they negated the P, right? But then they didn't negate the other one. They kept not and not. So this is nothing. This is not an example of any statements we've gone over. We already figured out that C is the answer. Let's look at D. Contrapositive. The contrapositive is if a number is not odd, then the number is divisible by 2. So what they did was that they negated. So here they negated the hypothesis and they negated the conclusion. How did you know that they negated this conclusion? The reason I know that they negated the conditional statements, the conditional statements conclusion is because they took out this not. When you negate a not, you just take it out. So this was actually the what? The inverse, right? Because I have my conditional, and what did I do? I have my conditional and I negated both the hypothesis and the conclusion in the same order. So this is not the contrapositive, this is the inverse. So my answer is C. This question will be on your test, okay? So make sure you study it. Okay, so now let's look at this. What is this? Write the converse of the following statement. If the converse is true, write true. If it is not true, then provide a counterexample. So if x is less than 0, then 9x is less than 0. So the first thing you should do, guys, on your paper, please do the converse on your own. Do not try to look at it through these answers. You will get confused. So let's write the converse of this. If 9x is less than 0, then x is less than 0. Okay, so let's start looking. This is the converse right here. So let's start looking at what things we can take off. Okay, this is wrong because they completely switched the sign. Switch the sign. Switch the sign. And switch the sign again. There's no greater than or equal to or less than or equal to here, so I don't know what they're doing. They're just trying to trick us. Okay. So we got that it could either be A or E. So now let's look at the reason. Is this true? Okay. To figure out this is true, let's actually solve for this. So over here, we're going to solve for this. So 9x is less than 0. What is 9 divided by 9? That takes it out. So x is less than, what's 0 divided by 9? That's 0. So that means this is true, right? Because what does it say here? This should be what's on this conclusion, and it is. So this is true. Because when I did this, what did I get when I solved for x? I got x is less than 0. So this is true. Okay?